Hello friends, welcome to the next lecture in this series. In this lecture, we are going to give you an understanding of the vehicular level of service and capacity concepts. Like we had discussed in the earlier lectures, there are several NPTEL courses that go in depth into the vehicular level of service calculations and capacity calculations. However, since our course deals with multimodal transportation, we still want to give you an understanding of the vehicular concepts, but we'd go more in depth into the non-motorized and public transport concepts. So, in this lecture, we are going to tell you about quality and level of service concepts with explaining what are these service measures or performance measures, and then get into step by step process of determining level of service for multi-lane highways and signalized intersections. So, when we talk about quality of service, this is something that describes how a transportation facility operates from a traveler's perspective. Okay. So, we have often looked at transportation facilities from the point of view of the operators or the service providers, but what quality of service does is it allows you to judge a facility or determine how good a facility is from a traveler's perspective. So, for example, factors that would affect quality of service include travel time, speed, delay for the people who are using the facility. Travel time may also be further discussed in relationship to its reliability of travel time. Comfort, convenience, this is something that is more and more becoming relevant in the field of transportation when it comes to measuring quality of service. And then also the availability of information about services, right. So, nowadays in the digital era, we all want information beforehand of where a bus is or where a train is or when is the next bus coming or what is the congestion level at a street where we are going to next drive. So, all of these affect the quality of service that is being provided. So, the quality of service that is being provided by either a bus system, by a metro system, or even by the highways on your urban area, right. So, that is what is meant by quality of service. Now, the quality of service is taken, since it is a qualitative measure, it is then converted into a quantitative measure by something called a level of service. So, what level of service does is it stratifies the various performance measures into different categories and each one of them representing a quality of service. So, level of service is the quantitative stratification of a performance measure or measures that represent quality of service. So, you can convert the qualitative measure into a quantitative measure, and then the level of service often is represented or shown in a through F scale, just like how we get grades in a class or a school, A being the best and F being the worst. So, often you will see in case of highways, there are different levels of service for different facilities. So, they all depict saying if the level of service is A, then from the point of view of the users, that facility is providing the best service possible, whereas if it is F, it is providing the worst service possible. Now, this also, although it is from the point of view of the users, it also takes into account the operators' possibilities, right. So, the operators may require a huge amount of money in order to maintain the service that is expected by the users, but that may not be feasible. So, the operators, then a middle ground is often reached to determine what is level of service A, B, C, D and so on and so forth. So, in all of this, in quality of service and level of service, essentially the measure that is being used is called the service measure. So, service measures are performance measures used to define the level of service for transportation system elements. So, what should this service measures have? So, the service measures should obviously reflect the traveler's perception, but it should be also useful to the operating agencies, right. So, here is the way in which quality of service or level of service is associated also not only with the traveler's perception, but also with the operating agencies. It should be directly measurable in the field, otherwise it is very difficult to quantify them, right. If it is purely qualitative, then or purely subjective, then it is very difficult to quantify. So, it has to be directly measurable in the field and should be estimable given a set of known parameters. So, if you know something, you should be able to estimate these service measures. So, we will explain all this in terms of a few understanding of a level of service of few different things in this lecture. Service measure examples include, so when we talk about the automobile mode of transportation, in case of multi-lane highways, usually what we measure is density. Now, density of a traffic stream, density is measured by, so it should be directly measurable in the field. So, it can be measured by number of passenger cars, that is PC, number of passenger cars per mile per lane, right. Since these all terms were developed in the United States, so they use miles, we could use kilometers, that is not a problem. So, passenger cars per mile per lane. So, now that is the directly measurable in the field. Now, how does it reflect traveler's perception, you would ask? So, density is nothing but it is the ability to maneuver within a traffic stream, right. So, it almost represents ease of maneuverability. So, when you ask a driver, he or she is driving on the road, if he or she cannot maneuver the vehicle in a proper fashion, then he or she would say that the maneuverability is poor or the density is very high. So, that is how traveler's perception is included in this service measure, which is density. Again, it is useful to the operating agencies because density is directly a measure of how congested a road is, right. If the density is high, then the road is congested, and the road is congested, then the travel times are very long. So, it helps the operators determine the level of congestion along a street, so they can route traffic in different ways and so on and so forth. So, you see one measure, one service measure, right. So, density is a service measure which can be used in the case of multi-lane highways for the automobile mode, that reflects a traveler's perception, that reflects is useful to operating agencies, measurable in the field, and also if you know certain parameters, you can estimate density, and we will tell you what those parameters are and how density can be estimated. Similarly, if you talk about the same multi-lane mode and how bicycle level of service can be calculated. So, it can be calculated using a bicycle level of service score, and similarly for urban streets, the pedestrian level of service can be estimated using a service measure called pedestrian level of service score. So, this is how you make the connection between service measures, quality of service and level of service. So, now if you start looking at the level of service of various transportation facilities, they can be determined for highways, for intersections, for other types of road users including transit, bicycle and pedestrians, right. So, even within highways you can determine the level of service of a expressway or freeway, a multi-lane highway, a two-lane highway and also an urban street. So, similarly for intersections you can look at signalized and unsignalized intersections and so on and so forth. So, in this lecture series, since we are concentrating on giving you an understanding of the vehicular level of service, we will explain to you about multi-lane and signalized intersections. Why did we choose multi-lane and signalized intersections? Because our overall topic of this NPTEL course is urban transportation facilities. So, in urban areas mostly you will find multi-lane roads or multi-lane highways and also a lot of signalized intersections. So, you should be able to gauge how well these are performing from your point of view, from a user's point of view, which is also useful to an operator. In the other lectures that follow after the first set of lectures, we will look at detail on the transit, bicycle and pedestrian modes, which is the more focus of urban transportation systems in this course. So, when we are talking about highway level of service and capacity kind of go hand in hand, and the basic concept of highways, as if you have taken other NPTEL courses of highway engineering or highway transportation and highway operations, you would know that the basic understanding of level of service and capacity is in the understanding of traffic flow, and traffic flow can be given by the time space diagram and the 3 parameters of flow, speed and density, which are related to each other in this fashion, where flow is equal to density times speed, or speed in this case we use space mean speed, right. And this is a very common and basic diagram of time and space, where if you say that there are 6 different vehicles and these lines indicate their trajectories. So, at any point in time, time 0, you will see that these vehicle 1 is at a distance d 1 from that point, vehicle 2 is at a distance d 2, vehicle 3 is at a distance d 3, d 4, whereas vehicles 5 and 6 will arrive at that point at a later time, right. They have still not arrived at that point where t is equal to 0, they are still approaching that point. So, if it is distance, if it is space time diagram, the slope of each of the trajectories will give you the speed, and the slope and the distance between two trajectories, right, can give you either what is called a time headway or a space headway, right. So, the time headway is the time distance between two vehicles at any point, right. So, at this point, at whatever this distance point is, at that point the two vehicles, vehicle 3 and vehicle 4 have a time gap of, or a time headway of h 3 minus h 4, right. So, time headway is nothing but the time when the front of the first vehicle crosses a point and the front of the next vehicle crosses the same point, that is called a time headway. And similarly, space headway for two different vehicles, for the same the 3 vehicles, the third vehicle and the fourth vehicle, would be at any particular point in time what is the distance between the two vehicles, right. So, the distance between the two consecutive vehicles at any point in time is called the space headway time. So, this is the basic understanding of traffic flow when you are trying to develop a level of service of highways. So, these are basic definitions of all this. Flow is the equivalent hourly flow rate at which vehicles pass a point on a highway during a time period that is less than 1 hour. So, it is given by this equation, and density, as is very common, is the number of vehicles travelling over unit length of a highway at any instant. It is given by this. Similarly, space mean speed is the harmonic mean of speeds, right. So, when we are talking about speed, we usually in traffic engineering or in development of level of service, we use space mean speed and not time mean speed, and it is given by this simple formula. And capacity of a freeway or expressway is the maximum sustainable hourly flow rate in one direction based on peak 15-minute rate of flow, and it is expressed in terms of passenger cars per hour. So, it is the hourly flow rate. So, number of vehicles passing or point per hour based on 15-minute peak period. So, this is another concept in level of service. We always look at the peak 15-minute period, because that is the worst traffic condition. So, we have to always design our facilities for keeping in mind the worst condition. So, if we fulfill the worst condition, then any condition better than that will also be fulfilled. So, we are always looking at the worst condition and designing facilities for that. So, now let us go through quickly the steps that should be followed to calculate the level of service of multi-lane highways. So, in the first step, you need to have a set of inputs of the existing conditions, which include the volumes, the lanes, the lateral clearance, the access point per mile, percent of vehicles and driver population. All this are inputs to your highway level of service calculations. After knowing these inputs, you calculate what is called the free flow speed and select one of the free flow speed curves. There are multiple curves. After knowing the free flow speed, you calculate the flow rate of the facility and then estimate the speed and density from which you will get the level of service. So, let us look at how do you compute free flow speed. It is given by this empirical equation of the base free flow speed of a multi-lane segment minus, this is the base free flow speed, and minus a bunch of adjustments, right. So, the base free flow speed is always developed keeping in mind ideal conditions, right. So, ideal conditions saying the lane width should be I guess 12 feet, there should be a certain amount of lateral side clearance, that means there should be enough space for the vehicles to move within the lane, right. There should be what type of median it is. So, always it depends upon if there is no median, then the speed is affected. So, capacity will be affected and level of service will be affected if there is a wide median or a grassy median or even just a barrier between the downstream and the upstream flow, then there will be variations in level of service. So, we have to adjust for all of this, and we have all standard values that are given in the highway capacity manuals that was developed in the US, and now India has also adopted and used the values as per our local conditions. So, these are the different types of adjustments that you have to do to determine the free flow speed of your particular facility or estimate the free flow speed of your particular facility. Then once you know the free flow speed, you have to adjust your determine the demand flow rate, So, you may already know the volume on the because volume is one of the inputs, you already know the volume, but you have to know the demand rate, and again this has to be adjusted based on the peak hour factor. So, which hour you are calculating the flow rate, that the number of lanes, and then another set of adjustments, which is adjustment factor for unfamiliar driver population and adjustment factor for percentage of heavy vehicles. So, if any traffic stream has a lot of people who do not understand or who are new to the facility, then your level of service will differ, and also if a facility has a lot of heavy vehicles, your level of service will differ. So, that is how for that reason you have to calculate the demand flow rate equivalent to the base conditions, right. You know already the volume, that is an input. So, once you know that, once you know your flow rate and you have estimated your space mean speed, you can determine density using this simple formula, and this is what I was referring to when I was saying that if you know certain parameters, you can estimate density. So, density is the service measure that is used to develop level of service for multi-lane highways. Okay. So, motorist evaluation of the quality of driving experience. Again, remember, it can be estimated in the field, it can be it is useful for the operators, and also reflects the quality of driving experience from the point of view of the motorists. That is how you should choose a service measure to determine the level of service. Then there are standard curves that are developed and standard tables that are available to you depending upon the density, depending upon your flow rate, and depending upon your passenger car speed, average passenger car speed. You can find out whether your multi-lane highway is a level of service A, is operating at a level of service A, B, C, D, or beyond E is F. So, you can find out this using either the chart or using the standard using the density values, and against the density values you can calculate the level of service given the different free flow speeds. Okay. So, that is how in a nutshell you can determine the level of service of a multi-lane highway facility that is existing in your urban area. Similarly, let us look at determining the level of service of signalized intersections at your urban area. Now, determining signalized level of service of signalized intersections is a little bit more complex, because it involves understanding under a deep understanding of the traffic flow in your area, and especially in our case, in the Indian case, where the traffic flow is very heterogeneous. You have to convert a lot of vehicles into equivalent PCUs, passenger car units. Non-motorized vehicles, two-wheelers, three-wheelers, all have to be converted into a standard equivalent PCU. So, it takes a lot of calculations, assumptions. However, there is a structured way of doing it. So, as long as you follow or understand the way, the later operational details you can always pick up. So, first is to understand or determine the movement or lane groups. We will tell you what lane groups are, because that is very important metric in determining the level of service of a signalized intersections. Then you determine the movement group and lane group's flow rate, right. We already know what flow rates are. We did after knowing the flow rate, you determine what is called an adjusted saturation flow rate. You determine how much proportion of the vehicles are arriving at that intersections when it is green. It is very important you do that. Determine what the signal phase duration is. Then understand what the capacity and the volume to capacity ratio is. Estimate delay, which is the service measure on which the level of service of signalized intersections depend. So, it depends on the volume to capacity ratio and delay, and that will give you the level of service. So, quickly again, level of service is represented by control delay. Control meaning it is the control device, it is the device that is controlling that intersection, that is why it is called control delay. So, you can always change the signal timing, right, that is under control. If it is an unsignalized intersection for which also level of service can be determined, that delay at an unsignalized intersection is called uncontrolled delay, because there is no control there, you have no control over that intersection. So, in this case LOS is represented by control delay and V by C ratio, and LOS is computed for each lane group. So, now what are lane groups? So, you see if at an intersection you can go in all three directions, and your movement groups at each green all the three directions are possible, then your lane group, you can group all those three movements into one, saying that that is one lane group. However, if you have exclusive left turn, since this is again in the US, in our case it will be an exclusive right turn, and then you have a through and a right, in our case it will be through and left, you can have two lane groups, right. One lane group is your exclusive left, in our case exclusive right, and the other lane group is through and right, in our case through and left. So, there are two different lane groups that can go through the signal at two different times, right. So, when you are developing a level of service, you are looking at each lane group, the delay the vehicles incur within each lane group, right. Delay per vehicle incurred during the operation of a lane group. You can then add it up, you can sum it up to tell the approach delay. So, at one approach there may be 3 lane groups. So, if you have individual lane group delays, then you can sum it up to say approach delay, and then you can sum up all the approach delays to know the delay of the entire intersection. You can do it any 3 ways, but the lowest unit is the lane group delay. Okay. So, that is what it is, each lane group, each intersection approach or intersection as a whole. Now, the capacity of a signalized intersection is the maximum rate of flow for a lane group again. So, we always concentrate on that lane group that can go through the intersection under prevailing traffic, roadway and signal conditions. The maximum rate of flow for a lane group that can go through. Okay. Again this is measured for during the peak 15-minute period, emphasis on major movements, and lane groups consist of one or more lanes, as we already know. So, usually we emphasize if a signalized intersection has one major road and one minor road, we usually emphasize the major road movements, so that majority of the traffic is catered for, but we also keep in mind the minor roads, but cater for the major road movements. Now, the capacity or the maximum rate of flow or the saturation flow rate is used to determine the capacity at the intersection. So, the capacity at the intersection is given by a product of saturation flow rate of each lane group multiplied by a ratio of, it is called the green ratio, the ratio of the effective green time and the cycle length. So, here we are not going to much detail about what each these things are, but if you want to know cycle length is the green time given to. So, the start of the green in one leg and the time elapsed before the green again comes to that lane group, right. So, if you have 4 lane groups and it starts at time t1 here, the green starts at time t1 here, and again the green, it is green here, then it is green here, and then it is green here, and the time elapsed till again the time t2 that has elapsed till again this intersection has green. So, the difference between these two time is the entire cycle length, and effective green time is essentially the vehicles do not get the entire green time to cross. There is a yellow amber time and a red time. So, if you substitute, if you subtract those times and some lost times, that startup lost time and time to decelerate and stop. All those times, if you subtract from the green time, it is called as effective green time. So, the capacity of an intersection is given by this equation. And then you have to know the V by C ratio. So, the V by C ratio, or it is depicted by x of any lane group, is given by this equation, which is a direct derivation from the previous equation. So, if you just divide this by V by C, it becomes V by, we already know the capacity equation for the capacity is this. So, divide this and V by C ratio. So, if any signal has saturated signal has an x is equal to 1, whereas an oversaturated signal x is greater than 1. Saturated signal meaning all the vehicles that are approaching the signal during the green time will cross the signal, that is either saturated or unsaturated, whereas oversaturated meaning all the vehicles that are approaching the green time will not be able to cross the vehicles and there will be some Q left over. So, that is called an oversaturated situation. Now, we always have a base saturation flow rate, which is usually the default values 1900 passenger cars per lane per hour, which is the maximum rate of flow across the stop line that can occur. However, this is again ideal flow rates or base saturation flow rate is always ideal. It has to be adjusted, and again for adjusting it you have to use a lot of factors, multiply them with a lot of factors, adjustment factors, which include adjustment factors for lane width, percentage of heavy vehicles, area types, if it is a CBD versus in a suburban area, if there is a lot of parking around there. So, all of these factors have to be adjusted for in order to know the adjusted saturation flow rate. Once you know the adjusted saturation flow rate, you determine what is called the critical lane group, right. So, if an approach has 3 lane groups, like I said, there would be 1 lane group that would have the maximum V by C ratio, that would have the maximum V by C ratio, and that would be called the critical lane group. So, you have to always cater for the maximum or the worst condition, right. So, that lane group requires the maximum green in order to go through the signal. So, if you take care of that lane group, you would be able to cater to the other 2 lane groups automatically. So, we already know the equation for V by C ratio, and this is the cycle length and this is the effective green time. So, this is cycle length by effective green time, meaning cycle length minus all the lost times. So, if you do this using this formula, you would be able to calculate the V by C ratio of the lane group, which is critical. Once you know the critical V by C lane group, you then calculate what is called the control delay or the average control delay per vehicle for that lane group. The average control delay is a summation. So, this is the average control delay, it is a summation of 3 different types of delays. One is the uniform delay, the incremental delay and initial Q delay. Uniform delay is nothing but it assumes that all of the vehicles arrive at a signal uniformly at a uniform rate, whereas incremental delay says that no, they do not arrive at a uniform rate, they arrive at a non-uniform rate, and what it does and what it says is that the demand may exceed capacity. Incremental delay takes into account that demand may exceed capacity, whereas uniform delay says that the saturation rate would never be arrived at, and there is always a uniform way of arrival. Whereas initial Q delay says that, well, even if incremental delay is there, incremental delay says that there may be oversaturation, but or there may be demand that is exceeding capacity, but there will be no Q left at the end of the green. So, all of the vehicles arriving will be moving through the green time, whereas initial Q delay says that no, there may be situations when there is a Q left over from the previous green time, because the green time was not sufficient to move all of those vehicles. So, they were further delayed. So, there may be 3 different types of delays, and the summation of those 3 delays gives you what is called the average control delay. So, these are all empirical formulas that have been developed over years. I believe the incremental Q delay in the newer version of the HCM has a more detailed formula than this. This may be from the previous highway capacity manual, but these two formulas are empirically still valid. And if you just in this case, a progression factor is used to multiply with the uniform delay. Progression factor is nothing but if the signals are coordinated with each other or are they isolated signals. If they are isolated signals, there will be very little progression of the vehicles moving from one signal to the other, whereas if they are coordinated signals, there will be some progression, and that progression factor is kind of multiplied with the uniform delay. So, once you know the control delay, you can then determine the level of service depending upon where your delay, what your delay numbers are. You will be able to determine whether they are in A, B, C, or D, or F. This table is for all V by C ratio, all conditions where V by C ratio is less than or equal to 1. So, they are not at oversaturated, they may be undersaturated or just at saturation. Anything oversaturated will always have a level of service F, 80 or greater than V by C ratio. So, that brings us to the end of this lecture. These are some references for your further understanding, and most of the topics have been taken from most of the lecture notes have been taken either from the Garber and Howell textbook or the highway capacity manual. So, in conclusion, what we have looked at in this series or this lecture series is the concept of quality and level of service, and how all of them quality and level of service is integrated with each other through these service measures, and how level of service is calculated for vehicles on a multi-lane highway as well as on a signalized intersection. There are different service measures for each of them. We looked at how density can be calculated in case of multi-lane highways, and we also looked at how V by C ratio and delay can be calculated at a signalized intersection. Thank you.